Let's see some of the core bottlenecks when ingesting data in ClickHouse and why they happen. So first thing is throughput versus latency. Usually you want to achieve that sweet spot in which you have high throughput at the lowest latency possible, but there are several problems in here. If you make a bunch of tiny inserts, what's going to happen is ClickHouse is going to create too many parts. Actually, there is an exception, that's too many parts. And it's very likely that you're going to kill the cluster. On the other hand, if you do big inserts, if you batch insert, what's going to happen is you can risk latency. You're going to take more time to process those inserts, and you're going to need more memory for that. In production systems, what you usually do is you enable async inserts, so ClickHouse is going to automatically buffer the rows, and then you have a couple of system tables, system parts, and system merge, and you can monitor them together with your CPU, memory, and I/O, which is your merge budget, and you do some simple throughput math in which you calculate the number of parts you can create per second and adjust this insert block size. We've seen how merge read many small parts and write larger parts, and they consume CPU, disk, I/O, memory, etc. What you have in ClickHouse is a couple of settings to control how much threads you assign for that background merge pool, okay? Also for mutations. What you have to do in these cases is assign a value as high to not create a backlog of merges, to not create lag on how parts are being merged together. Also, do not produce a replication queue. Remember, different replicas have to coordinate themselves, so whenever a new part is created, there is a replication queue in Zookeeper, so the other replicas know there is a new part they can use for reads. So yeah, it's a fine balance in which, again, you have to try to not produce replication and merge queues, and you have some knobs, some settings, very low level settings you can tweak depending on your workload. Depending on your ClickHouse cluster layout, writes and reads can share the same system resources, CPU, disk, and memory. The balance, it's a little bit hard to achieve because if merges fall behind, what's going to happen is you're going to increase your ingestion latency, you're going to have a merge backlog, replication queue is going to grow. This is a huge problem. If you are very CPU intensive in merges, then your queries are not going to have resources to run. So it's very hard to pause one or tune one without affecting the other one when you have shared resources. And you may think, okay, I can go with separate replicas for writing, other for reading, so there is no shared CPU resources. I can do zero copy replication, so we don't have the disk problem. Parts don't need to travel from one replica to the other. But even in that cases, coordination never disappears. So each replica is going to have its replication queue, and even when you have zero copy, replicas need to know about the different parts that are available for reads. One important part is zero copy replication is not available in the open source ClickHouse version anymore. And if you're thinking on adding separate writing replicas or multiple writers, this is going to complicate cluster management at different levels. When ingestion slows down, ClickHouse signals back pressure. There is a couple of settings to delay or error inserts when the number of parts is growing. But you're going to have a couple of problems in here. First, you need a way to rate limit your clients, and you need to make sure they retry again because you are failing those inserts. And when you need your clients to retry, you're going to have the deduplication problem. This is hard to implement correctly under load, and you can end up like duplicating several millions of rows, depending on your workload. The worst part could be even losing completely your data. Now ClickHouse benchmark is going to tell you this, which is systems are not immutable. You're going to need to evolve your schemas. When you do it, you're going to need to do data migrations, backfilling historical data. So the question is, can you keep your system running while you do these schema changes? There are several challenges on this. First thing is the primitives ClickHouse provides for schema changes usually trigger mutations, and we already saw how mutations need to rewrite complete parts. So this is going to compete with your merge budget, with your resources. Something important, and then you learn once you are in production, is in real clusters, you have ingestion and live queries. Then you do some change in your schema, and you have to simultaneously completely backfill the history to adapt to the new schema. So you have different moving pieces at the same time you have to manage correctly. And talking about backfilling, we will have a separate video completely about this. The most simple version of a backfill is doing like insert into select from your previous table. And again, this is a costly operation. This is going to spike on memory, on I/O, CPU. In the end, you are dealing with a complex system. You're trying to do ingestion yourself in ClickHouse, and there are different knobs, settings, metrics, and system tables you need to watch. It's very important that you measure how many active parts per partition, if the merge queue is growing, how many memory and disk throughput, if there are mutations, different zookeeper queues, DTL, replication queues, if there is lag in the replication, any other latency in zookeeper. There are some other backpressure indicators, if there is an increase in the insert latencies, even if there is an increase on your P95, P99 select latencies, then that's an indicator that something is wrong. And ClickHouse clusters are not static. They need to adapt to the load. So you're going to do some of these operations, adding and removing replicas, dropping tables. You may have long-running queries when turning off replicas, and maybe you cannot do that. You may have S3 error you have to monitor. So there is complex set of operations you have to do that you need to take into account what's going on the cluster at that time.